right, so today for 5.5, we're going to learn about the trapezoidal rule. And so we did a rectangular approximation method before. And so if I had a function that looked like this, we said that we could calculate the area under the curve from A to B, right, by making like little rectangles, right? But the problem with making the little rectangles is the accuracy. At some point in time, when I make the rectangles, there's always these little gaps that aren't being measured. Okay? And that's okay, I suppose. But it's not, if we wanted to be more precise, well, maybe the rectangle isn't the best way to do that. So the trapezoidal rule does something different. What they suggest is that you make a trapezoid. In other words, you're going to have a line that goes from here to here, a line that goes from here to here, and a line that goes from here to here, and a line that goes from here to here, and a line that goes from here to here. Now, if I take, God bless you, if I take and make a trapezoid like that, it tends to be, in other words, if I fill those in, these are all little trapezoids, and they seem to be more accurate, especially if I let delta x approach 0. Right? So each one of these, the height of the trapezoid is delta x. And so if I were to take this out, I end up with a trapezoid that looks like this. And from your geometry days, if I take that trapezoid and I rotate it, whoops, I want to put them both together. If I take that trapezoid and I rotate it this way, put that back there, and I rotate it this way, the way that we would find the area of the trapezoid, I'd have base 1, base 2, and then this right here will be the altitude height. And so the trapezoid, the area for the trapezoid is 1/2 times base 1 plus base 2 times the height. And so how that translates in our calculator, this is really how your calculator calculates the area under the curve. But the way that looks is we can approximate the area under the curve from A to B of f of x dx by taking the height, which is going to be h over 2 times y sub 0 plus 2 y sub 1 plus 2 y sub 2, and then you go all the way to y sub n. Now the reason we're writing the 2 is because if you look at this, I'm going to count this line twice. Okay? So this would be like y sub 1, or y sub 0, and this would be y sub 1. And so I have to count y sub 1 twice because it's on this trapezoid, but then it's also on this trapezoid, right? And so then I need to list that twice, and then the same with y sub 2. I need to list that twice. But the one in the front only gets counted once, and this line on the end, y sub 1 or y sub n, only gets counted once. But all the ones in between get counted twice. And so that just comes from calculating the area under the curve. And your calculator can do this. And actually, your calculator does that. Well, let's do an example, and then we'll compare it with the calculator. So for example number 1, we're asked to find the area of the curve from 1 to 2 of x squared. And just to remind you guys what that looks like, it's a parabola that looks like this, and if I go from 1 to 2, so I want to find this area under the curve. Okay? And it also tells me to do it in 4 partitions. Alright? So we can estimate this if I have 4 partitions. In other words, I'm going to go 1, and 2, and then divide that into 4 partitions. So I'm going to have 4 trapezoids like that. And I need to calculate all those values. So if I do this by hand, I can find the area under the curve of the trapezoid by plugging in my h value over 2, right, times y sub 0 plus 2 times y sub 1 plus 2 times y sub 2 plus, so this would be y sub 0, 1, 2, 3, and 4. So when I get to y sub 4, I do that by itself. So I got y sub 3 plus y sub 4. And those are just the corresponding y values evaluated at the x values. So the first thing I want to do is I want to figure out what h is. Now we can calculate h. Let me make my h a little more profound. This h can be calculated by taking the upper limit, which is 2, subtracting the lower limit, and dividing by 4. Now we say h, really that is the height, but that's also delta x. So if you don't remember the formula, delta x is equal to b minus a divided by n. And so my h value is actually 1/4. So 1/2 of 1/4 is just 1/8. Then I just need to evaluate these functions. So now if it's 1/8, what I need to do is I need to figure out what this y sub 2 and y sub 1 and all that business is. Well, 1/8 is a decimal, and so I need to evaluate f of, the first value is 1, so I need f of 1 plus 2 times 1.125, or 2 times f of 1.125, 2 times this quantity, f of 1.125, and then plus 2 times f of 1.25 plus 2 times 1. How many of those did I have? .75. Wait, why is that not right? 1.75, and then the next one is just plus f of 2. Okay. Wait, let me think this through here. I've got 1 for, oh, it's 0.25. Okay, that's where I messed up. I'm doing 1/8. But really it's 0.25. So this is 1.25. All right, I made a mistake. So this would be 1.5. The book has it written in fractions, and I was trying to be, because this is how you'll plug it in your calculator. Plus 2 times 1.75, and then f of 2. So now to do that on your calculator, there's a couple ways you can do it. We'll just do it by hand. I'm just going to figure out what f of those values are, and we'll plug it in. So I'm going to do this one by hand. If I hit my original function is x squared, so I'm going to hit x squared. Now if I go into table set and I start at 1 and I do delta x as 0.25, cool thing about that is I can get the table and I'll find all the values, okay? And so, or you could do it by hand, but really I have 1/8 times 1.56, so we have 1 plus 2 times 1.56 plus 2 times 2.25 plus 2 times 3.625 Let me move that down to the other line. So it's 3 point this. That's why it was wrong. All right, so let's go back and fix that. So if I say 1 plus 2, whoops, plus 2 times 1.56 plus 2 times 2.25 plus 2 times 3.0625 plus 4. Okay, now I divide that by 8. There we go. So I got 2.343. So this is approximately 2.343 using the trapezoidal rule. So that's not the exact amount, but that's approximating using the trapezoidal rule. So that was from 1 to 2 of the function x squared dx. Okay? So now we're going to calculate that and see how close we are. So we got 2.23. So now if I go to math and I hit option number 9 and I say x squared, comma, from 1 to, oh wait, I got to tell it to do x, comma, from 1 to 2, pretty close. It's off by 1/100th, right? The actual value is 2 1/3, right? So the actual value is 2.3 repeating.